So now we are going to be loading the tooth growth data sets, which I'm going to run. I have an example here. We're going to be applying the one sample t-test. It's usually used to check the quality of a mean. So for example of the one sample t-test is usually used to check if the average of a particular population is equals to a particular value. For example, now we have example here now is the average tooth length different from 18 millimeters. We have a population now. I want to find out if the average tooth length is 18 millimeters. So now the null hypothesis is going to be that the average tooth length is equals to 18 millimeters, and we have the alternative hypothesis that the average tooth length is not equals to 18 millimeters. We are going to use the one sample t-test to find out if the average tooth length is equals to 18 millimeters. So now this is our tooth growth data set. As you can see, let's see the average tooth length of the tooth growth data set. I'm going to say mean tooth growth, and I'm going to be using the length. So you can see that it is 18.813. So this is it, 18.813. Now we are going to be testing this particular. This, just assume that you don't know this particular value. Assume that you don't know it. I want to see if the average tooth length is 18.8133, which is approximately that, or close to the actual mean. I'm going to be using the one sample t-test. This is the t.test function. First of all, I give my vector, which is the tooth growth length. Your alternative hypothesis can be of various types. I told you that the null hypothesis is hypothesis of equality. Why the alternative hypothesis is hypothesis of inequality? If your null hypothesis says that the tooth growth length is 18 millimeters, then your alternative hypothesis can come in three forms. It can either be not equals to 18, which is a two-sided alternative hypothesis. We call it a two-sided alternative hypothesis. Or it can be say that no, the alternative hypothesis can say that the tooth growth length is less than 18, which is a one-sided hypothesis. So this one-sided hypothesis can either be to the left if it is less than, or to the right if it is greater than. So that's why you can see that this alternative hypothesis here was specifying that it is two-sided. You can see it is showing that it's two-sided. If I should say less than 18 here, less than 18, then I'm going to be changing it to, I'm going to change this particular value here to less. And if I say greater than 18, I'm going to change greater than, I'm going to change this to greater. So this is how this particular argument works. And now mu is our mean. So what is the mean that we're talking about? Is 18. Now I'm going to run the whole of this. So when I run this now, you can see that I'm having 0.4135, which means that we're not going to reject the null hypothesis. Because if your p-value is greater than 0.05, you will not reject your null hypothesis. But if it is less than 0.05, you reject the null hypothesis. So I'm not going to reject the null hypothesis. I'm going to accept it that the mean length is 18, which is actually close to the actual length. But if I use something like 15 now, 15 is not my actual mean in my data set. But I'm using it now because maybe somebody brought an assumption that the average tooth length is 15 millimeters. So let's see, is that true or not? I'm going to run this. So you can see that now the value is less than 0.05, which means we are going to reject the null hypothesis that the average tooth length is not 15. Can you see it now? And when you check the data set, the actual tooth length is approximately 18.8 something. So this is how the one sample t-test actually works. It's used for actually verifying the actual mean of a particular population. If I should also try 20 now, I guess something like that. If I should try 20, so you can see if I should try 20, you see that the result still shows that this result doesn't reject the null hypothesis because it is still a value that is closer to the actual mean value. If I should try 25, let's see 25. You can see that we have 0.000 because this is very far from the actual mean value. And when I tried 20 earlier on, you can see that the percentage of probability, actually reduced is 23%. If I should try 19, because 19 is close to the actual mean which we had earlier on. The actual mean, can you see, is 18.8133 for the data. If I should try 19, which is closer to the actual mean than 20, you can see that it has increased. The value of the p-value has increased. If I should now say 18.8, now you can see now I have a 98%, 99% probability. So the higher the p-value, then the higher the probability of what that particular null hypothesis is true. So which means we are not rejecting it. The lower the p-value, then the lower the probability that particular null hypothesis is true.